So in 1909, a scientist by the name of Ernest Rutherford, wanted to learn more about the atom. And so he instructed his assistants, Mr. Geiger, who we now named the Geiger counter after, and Mr. Marsden, who I don't believe has things named after him, but I might be wrong, to run an experiment. And this experiment is known as Rutherford's gold foil experiment. It's very important because it helps scientists to understand more about how the atom was structured, where its parts are. So let's learn more about what this experiment told them. So what they did was they took a source of radioactive emissions, in this case, alpha particles, and they put this source in a lead-lined box. So here's our box. This is our radioactive source. And this is going to emit alpha particles. Alpha particles, as you should know, are positively charged particles. They are exactly like what a helium nuclei is like, which means that it has two positive protons. So here's the alpha particles. Remember we said they're positively charged. Because they had this lead-lined box around, these particles came out as a beam. Okay, so this beam is a positively charged beam of radioactive emissions. Now, they put a piece of gold foil. So let's do some very thin. This foil was very, very thin. They used gold because it could be hammered into a very, very thin leaf. And as we know, metals are malleable, and that allowed them to hammer it into a very thin leaf. So this is our gold foil. And then behind that, they set up a detector. They set up a detector, which when the just delete that and do a better detector. Here's a detector like that, which is basically a screen that if any particles would hit that screen, it would send a message to a counter. Okay, and what they noticed was that the majority of alpha particles went straight through. They went straight through and they just lit up this side, this part of the screen here. That told them some very important information. So we're going to call that number one. They did also notice that some particles got deflected. And we're going to call that number two because we're going to talk about what that told them. Some of them got deflected at quite wide angles, and some of them even got deflected right back towards the radioactive source. So what does this tell them? Well, at number one, the fact that most particles went straight through let them know that matter, and we know matter is made up of atoms, is mostly empty space. Okay, so the fact that all of these positive alpha particles, the majority went straight through, told them that matter atoms, the atoms are mostly empty space. Matter is mostly empty space. And if you want to learn more about this, you go and watch my video on the plum pudding versus the nuclear model. Number two, position number two, the fact that some of the alpha particles deflected let them know that, well, like charges don't like each other. So that must mean that in atoms, in atoms, there must be a positively charged area, which of course we now know are the protons in the nucleus. The nucleus is a positively charged area. So this helped them to develop further the model of the atom, comparing it to the earlier plum pudding model, which stated that there was lots of, it was a large positive sphere with no empty space and negative charges spread throughout. And they totally dismantled this theory because most of those alpha particles went straight through. So if they went straight through, that showed them that actually there was not much empty space. There was a lot of empty space inside the atom compared to what the plum pudding model said. And the fact that the plum pudding model also said that there was a large positive sphere and these alpha particles went mostly through, that would say that actually the sphere is not largely positive, but there are positive regions in that particular, in the atom. And so this is how we learn about the difference between the plum pudding model, which was the large positive sphere with negative charges spread throughout, compared to the nuclear model, which had the positive sphere in a nucleus and electrons, negative charges in shells, okay, around the nucleus. That's Rutherford's gold foil experiment and what we learned from it.